Good morning. Department of Collegiate and Technical Education. Highway Geometry Design of Horizontal Alignment Elements. Module 2, Section 5. Highway Engineering of 5th semester. Civil Engineering. Subject code is 18CV 56. Today, let us discuss about the overtaking side distance. The minimum distance open to the vision of a driver of a vehicle intending to overtake slow vehicle ahead with safety against the traffic of opposite direction is known as minimum overtaking side distance or passing side distance, popularly called as OSD. That is, in India, even though we design the road for the design speed, all the vehicles will not be traveling at the same design speed, say 100 kilometer or 80 kilometer. All the vehicles will not be traveling at 80 kilometer or 100 kilometer speed. Few of the vehicles will be traveling at 80 kilometer and few of the vehicles will be traveling at maybe 40, 50, 60, etc. So it is very much necessary that the fast moving vehicles overtake the slow moving vehicles on a highway. So distance which is available to overtake the slow moving vehicles by the fast moving vehicles before the vehicle which comes from the opposite direction. So that distance is called as overtaking side distance or OSD. The overtaking side distance is the distance measured along the center of the road with a driver whose eye level is 1.2 meter above the road surface and can see the top of an object of 0.15 meter above the road surface. So factors, what are all the factors which affects the overtaking side distance? Speed of overtaking vehicle, vehicle A. Usually the overtaking vehicle is the fast moving vehicle. Overtaken vehicle, vehicle B, which is the slow moving vehicle, and the vehicle which is coming from the opposite direction, if at all any vehicle, then we call that vehicle as vehicle C. So the distance between the overtaking and the overtaken vehicle, skill and the reaction time of the driver, that depends upon the skill as well as the reaction time, age, condition, climatic condition, purpose for which the driver is traveling, all those factors. Rate of acceleration of overtaking vehicle. So whenever the fast moving vehicle has to overtake the slow moving vehicle, it has to accelerate. The driver has to press the acceleration, he has to increase his speed, and then he has to overtake the slow moving vehicle. And the gradient of the road, if at all if any gradient is there on the highway, then that also affects the your overtaking side distance. So let us understand with this diagram the how the overtaking side distance is analyzed. Here we consider three vehicles, vehicle A, vehicle B and vehicle C. Vehicle A is the fast moving vehicle. Vehicle B is slow moving vehicle or a overtaken vehicle. Vehicle A we call it as a overtaking vehicle, and the vehicle C which is coming from the opposite direction. This is a two-lane road with a two-way traffic. The moment the driver thinks that he needs to overtake the slow moving vehicle, so let that position be A. The moment he thinks that during that reaction time, maybe 1 second, 2 seconds or anything, he will be traveling a distance what is known as a D1. Since he will be moving at a design speed of maybe 60, 70 or 80 kilometer, so he will be traveling for a distance of D1. Then once he decides that he needs to overtake the slow moving vehicle, so he has to change his path, then overtaking. So it happens with respect to some time, capital T seconds. Again, after overtaking, he has to come back to this position. So all these operations, right, should happen before the vehicle, which is called a C, which comes from the opposite direction. Let C1 during this entire overtaking operation, let the vehicle C travels from position C1 to C2. So that distance we call it as a D3. So this is D1. The entire overtaking operation, it will be traveling at a distance of D2, and during this time the vehicle which is coming from the opposite direction will travel at a distance from C1 to C2, traveling at a distance of D3. Here we assume that whenever the fast moving vehicle wants to overtake the slow moving vehicle, it will be at a distance of s. So both at this point of time, both this vehicle will be traveling at the same design speed. If this is 60, will also be 60. It's only for a fraction of seconds. Then he has to change this lane, then overtake, again come back to this position. So we assume that both this distance from the center of this vehicle to the center of this distance vehicle as s. Here also, after overtaking, it comes back to this position, the same s distance it will be traveling. Okay. So analysis, let d1 be the distance traveled by the overtaking vehicle, that is a fast moving vehicle a, during the reaction time t seconds of the driver from position a1 to a2. So it will be traveling from position a1 to a2 during the reaction time of t seconds. d2 is the distance traveled by the vehicle a from at to a3 during the actual overtaking operation, which is called as a capital T seconds. D3 is the distance traveled by the oncoming or the opposite vehicle C from position C1 to C2 during the overtaking operation of A. That is, in the entire T seconds, it will be traveling at a distance of D3. B is the overtaken or the slow moving vehicle. B is the overtaken or the slow moving vehicle with uniform speed. It will be moving at VB meter per second or capital VB km PH. C is the vehicle coming from the opposite direction at a design speed of v meter per second or capital V kmph. The distance traveled by the vehicle during this reaction time is d1 and is between the position a1 and a2. The distance will be equal to vb into t, that is speed velocity into time taken. Here the reaction time we assume it as 2 seconds, not 2.5 seconds. So finally, OSD is given by d1 plus d2 plus d3. So d1, that is velocity into time taken, that is 0.28 vv into t, plus d2 0.28 vv into t plus 2s, d3 0.28 into v into t. Here there are two unknowns, one is capital T, another one is s. So S is calculated, that is the spacing of the vehicle is calculated by using the formula 0.2 VB plus 6, where 6 is the wheelbase. In the previous class I have told that the wheelbase will be having a length of 6 meter. So here V is speed in km ph. If the same speed is expressed in meter per second, then it is 0.7 VB plus 6 meter, where here the speed is in meter per second. T, the total reaction time, is calculated by using the formula square root of 4 into 3.6 s by capital A. That is, A is equal to 14.4 s by A, where A is the acceleration in kmph per second square. Similarly, this can also be expressed as in meter per second square. Then that becomes T equals square root of 4s by small a, where A is the acceleration in meter per second square. Finally, we have this OSD equals d1 plus d2 plus d3. Minimum overtaking side distance is d1 plus d2 plus d3 for a two-way traffic. On divided highways and on the roads with one-way traffic, the overtaking side distance is d1 plus d2, as there is no vehicle which is coming from the opposite direction.
Overtaking zones. It is desirable to construct the highways in such a way that the length of the road visible ahead at every point is sufficient for safe overtaking. This seldom practicable, rarely practicable, and there may be stretches where the safe overtaking side distance cannot be provided due to site conditions. But the overtaking opportunity for the vehicles moving at design speed should be given at frequent intervals. These zones are meant for overtaking, hence they are called as overtaking. The minimum length of overtaking zone should be 3 times the safe overtaking site distance. That is, overtaking zone length is 3 into d1 plus d2 plus one-way traffic and 3 into d1 plus d2 plus d3 for two-way roads or a two-way traffic. Desirable length, even though the minimum length it is 3 times, but the desirable length is 5 times. The desirable length of the overtaking zone should be kept 5 times the overtaking side distance. That is 5 into d1 plus d2 for a one-way traffic and 5 into d1 plus d2 plus d3 for a two-way traffic. So here, the sketch I have shown here how much the overtaking zones should be there. It is 3 to 5 times the OSD. So this is the overtaking side distance length. So it should be 3 to 5 times. So let's discuss one of the example. The speed of the overtaking and overtaken vehicles are 70 and 40 kmph respectively on a two-way traffic road. If the acceleration of the overtaking vehicle is 0.99 meter per second square. So here you can see that acceleration value is given in meter per second square. It can be kilometer also. So calculate the safe overtaking side distance. Calculate the minimum and the desirable length of overtaking zone. Draw the neat sketch of the overtaking zone and show the position of signpost where you need to show that signpost. That is the start and also the end of your overtaking zone. Solution. So let's see what is the data given. Speed of the overtaking vehicle, that is the fast moving vehicle, 70 kmph. So that you can convert into meter per second. So divide by 3.6, 19.4 meter per second. Speed of the overtaken vehicle, that is a slow moving vehicle, we call it as a VP, 40 kmph. And if it is converted into meter per second, so divided by 3.6, 11.1 meter per second. So average acceleration during overtaking, that is a small a, 0.99 meter per second square. So as I told you, even it can be expressed in kmph. So if the kmph is used, then the formula will be different. So 14.4 and just 4a by s. So overtaking side distance is given by the formula d1 plus d2 plus d3. Okay, so that is d1 VB. Here we are using meter per second. So VB into T plus VB into capital T plus 2S plus V into capital T meters. So reaction time is 2 seconds. It is not 2.5 seconds. So D1 is equal to VB into T. So we have converted everything in meter per second. So 11.1 into 2 meter, 22 meter. So D2 is VB into T plus 2S. So here T is also unknown, S is also unknown. So just calculate what is the value of S and T. So what is the formula for S? It is 0.7 VB plus 6. It is 0.7 into 11.1 plus 6 meter. So if it is in kmph, you need to use 0.2 into capital VB. Okay, if it is in meter per second, it is 0.7. So S is 13.8 meter. T, capital T, square root of 4s by a, since the acceleration is given in meter per second square. Otherwise, it becomes 4.4 into 3.6, that is 14.4 s by a. Okay, so T is 4 into 13.8. So just now we calculated the value of s divided by acceleration 0.99. So 7.47 seconds. D2 is finally right 11.1 into 7.47 plus 2 into 13.8. Just substituting those values in D2 formula, we get 110.5 meter. Finally, D3, it is V into capital T. So the speed of V is 19.4 if you convert into meter per second into 7.47 seconds. So it is 144.9. So just add all those things. So OSD equals D1 plus D2 plus D3, that is 22.2 plus 110 plus 114.9. So we are getting 277.6 meters, say 278 meters. Minimum length of overtaking zone. So just now we discussed it is 3 times the OSD. Since it is a two-way traffic, we need to consider D1 plus D2 plus D3. Desirable length is 5 times OSD, that is 5 into 278 meter, so 1390 meter. So minimum length is 3 into 278, 834 meters. So the sketch here, you can see here, this is the OSD length. So the 278 meter, whatever we got. So before, this is the 3 to 5 times. Okay, so 3 is 834 meter and 5 times is 1390 meter. So this entire zone is the overtaking zone. So you need to show the signpost one before the actual start of your overtaking zone. This should be displayed at a distance of OSD length. So this SP1 is signpost 1. So what the SP1 says? It is the overtaking zone ahead or the start of your overtaking sign. Here SP2. So before it ends, you need to put one more signpost, that is end of the overtaking zone. Similarly, for the vehicle which is coming from this direction, so this is the position of SP1 before, that is 278 meter. So again, before it ends, you need to put a signpost at a distance of the OSD distance, that is 278 meters. Okay, so this is signpost 1, signpost 2, and this is signpost 1 for the vehicle coming from this direction, and this is signpost 2 that is showing the end. So assignment question: calculate the SOF overtaking side distance for a design speed of 96 km/h. Assume all other data suitably. So moving on, design speed. The geometry details of the highway mainly depends upon the design speed. So in the first class itself, we are discussing that the geometric details of the highway mainly depends upon the design speed. So let's see what is a design speed and what are the different speeds for different categories of road in India. All the important geometric elements such as side distances, radius of the horizontal curve, length of the horizontal transition curve, rate of super elevation, extra widening on the pavement at horizontal curve, length of the summit curve as well as the valley curve are dependent on the design speed. All the geometric features of the highway are basically depends on the design speed. The design speed of the road depends upon the class of the road as well as the terrain condition. So this is the IRC given guidelines, okay, for the different categories of design speed. I'll just uh, tell about the plain and also the rolling. So it is the expressways. So the rolling as well as the minimum. So minimum is 100, maximum is 120. NH and SH, it is plain on a plain terrain, 100 kilometer rolling, and the minimum is 80 kmph. MDR 80 and 65, ODR 65 and 50, VR 50 and 40. On a rolling terrain, so it is 100 kilometer for an expressway, minimum is 80. NH and SH, it is 80 and 55. Similarly, MDR 65, 50, ODR 50 and 40, VR it is 40 and 35 kmph. Similarly, you can see for the mountainous as well as the steep. This is very important. You need to remember some of the values for an expressway and also for the national and state highway, both in plain, rolling, mountainous as well as the steep terrain. So the recommended speeds for the design classes in the urban roads. Similarly, right? So in the urban areas, the IRC has given the speeds, but it cannot be 100 or 120 kilometer because of traffic and also because of various other problems. You cannot travel at that speed. So it is usually less. So for arterial roads, it is 80 kmph. Subarterial roads, if you remember the classification right in the first module of highway engineering, I will discuss about this arterial roads, subarterial roads, also collector street and also local street. Okay, so subarterial roads it is 60 kmph, collector streets it is 50 kmph, and the local streets it is 30 kmph. All the roads has to be designed for these design speeds. So let's discuss some of the multiple choice questions on whatever the discussions we had in this. The first one, the factors affecting the overtaking side distance, that is OSD, are speed of overtaking vehicle, speed of overtaken vehicle, speed of the vehicle coming from opposite direction. D, all of the above. So the answer is D because the OSD depends on all these design speed. Second question. The desirable relationship between OSD and the length of overtaking zone is OSD. It is 2 times OSD, 3 times OSD, or 5 times OSD. So it is the 5 times OSD. So minimum is 3, but desirable is 5. So the answer is D. Speed of the overtaken vehicle is 80 kmph. Then the design speed is 80, 96, 100 kmph, 106 kmph. So usually it is given by 80 plus 16, right? So 80 plus 16, 96. So the answer is B, 96 kilometer. If the speed of overtaken vehicle is 50 kmph, then the spacing of the vehicle is dash 10 meter, 12 meter, 14 meter, 16 meter. So it is 0.2 into V plus 6. So 0.2 into 50, that is 10. 10 plus spacing 6 meter. So it is 16. So the answer is B. The reaction time of the driver assumed in OSD is 1 second, 2 seconds, 2.5 seconds, 3 seconds. The answer is B, that is 2 seconds. The design speed of highway affects side distances, radius of horizontal curve and length of summit as well as the valley curve, length of horizontal transition curve and rate of super elevation, all of the above. So the answer is D. So it affects all these parameters: side distance, horizontal curve, vertical curve, transition curve, super elevation, everything. So everything depends upon the design speed. As per the IRC, the ruling design speed of expressway on a plain terrain is dash kmph. 100, 120, 150, 80. So expressways, it is 120 kmph. Answer is B. As per IRC, the minimum design speed for NH and SH on a plain terrain is dash kmph. 100, 120, 150, 80. So the answer is 80 as per the IRC data. As I told you, you need to remember those values. The design speed mainly depends upon class of road, terrain, both A and B, that is class of terrain, class of road and terrain, D, class of road, terrain and vehicle type. The answer is C, that is both class of road and terrain. It does not depend upon vehicle type. So the answer is C. As per IRC, the design speed in local roads in urban area is dash kmph. 60, 50, 30, and 45. So the answer is C, that is 30 kmph. Thank you.